Hello everyone, welcome to eMath Edge. My name is David Akwashki and I'm here to help you master mathematics and give you the edge you need to succeed in your exams. Here at eMath Edge, I will practically be solving mathematics past questions for senior school examinations, where I will be breaking down the whole process into simple, easy to understand steps. I actually understand that preparing for math exams can be really hectic, but understanding how to approach these questions, most especially the AC part, will ease you a whole lot of stress. And that is what this platform is designed to do for you. Each video is designed to boost your confidence and make math exam feel less like a mystery, but more like a basic thing you can conquer. So with that being said, let's get started. So here we have a simultaneous linear equation to solve, which is a wire question for 2021, question number 4. And the question says, solve using matrix method. 2x plus 3y equal to 13, which is the equation 1. 3x minus 2y equal to 1, which is equation 2. So we are to solve this simultaneous linear equation using matrix method. So let's go ahead and do that quickly. First, let's write out the equation 2x plus 3y, which is equal to 13, and equation 2, which is 3x minus 2y is equal to 1. Note that ax is equal to b is a formula for solving simultaneous linear equation using matrix method, where a is a matrix containing the coefficients of these expressions, which is 2, 3, 3, and minus 2. So let's write it down such that a is equal to, or where we have matrix A to be equal to the coefficient of those expressions, which is 2. The coefficient of 3y is going to be 3. The coefficient of 3x is going to be 3. And the coefficient of negative 2y is going to be negative 2. Matrix X is going to be the variable which we are looking for, x and y, and is going to be in vertical form, which is x and y. And matrix B is going to be a matrix containing the constant at the right hand side, which is 1 and 13. So we are going to have it here to be 13 and 1. So having brought out all the metrics from the question which we are going to work with, the next thing we are going to do is to check what are we looking for. We are looking for the value of x and y, right? And which matrix is containing those variables which we are looking for is matrix X. It contains all those variables which we are looking for. So in this formula, let's go ahead and make matrix X the subject of the formula such that we are going to have X to be equal to, now since we have AX equal to B, for us to make X the subject of the formula, what we are going to do is simply to divide both sides by A, such that A will go with A and we will be left with X. X to be equal to B all over A here, right? So another way to write this expression B all over A is simply to multiply B by 1 all over A, right? If you multiply B by 1 all over A, you are going to have B all over A. And this can simply be expressed as B A to the power of negative 1, or B multiplying inverse of A, or B multiplied by A inverse. So in a nutshell, we have the subject of the formula, which is X, to be B, matrix B, multiplying the inverse of A, where we have matrix B to be equal to, we have 13 and 1, right? And we don't know what the inverse of A is. So what we are going to do is to find the inverse of A. And mind you, earlier we looked at the inverse of A to be 1 all over the determinant of A multiplying the adjoint of A. Where I explained earlier, for you to obtain the determinant of a 2 by 2 matrix, what you are simply going to do is to observe the elements in the major diagonal or in the main diagonal, which in this case we have to be 2 and -2, multiply it and subtract the product of the elements in the other diagonal, which in this case we have 3 and 3. So let's quickly go ahead and do that. We are going to have 2 multiplying -2 minus the element in the other diagonal, which is 3 multiplying 3, 3 multiplying 3, such that we are going to have 2 multiplying -2 is going to be -4 minus 3 multiplying 3 is going to be -9, such that -4 minus 9 is going to give us -13. So this is the determinant of E. Now the next thing to do is to obtain the adjoint of E. And like I earlier stated, for you to obtain the adjoint of E, what you are simply going to do is observe the element in the major diagonal, which is, in this case, we have 2 and -2, right? So you are going to swap the element in the main diagonal. So swapping these two elements, 2 and -2, where my -2 is going to take the position of 2 and 2 is taking the position of the -2. So it's going to be -2 standing as the element in the first row, first column, and the other 2, which is in the first row, first column, is going to stand in the position of the element in the second row, second column in that case. So we are going to have it -2 and 2. The next thing to do is to introduce a negative sign to the element in the other diagonal, which is 3 and 3. So introducing negative sign to the element in the other side, we are going to have -3 here and -3 here. So this is the adjoint of that matrix A. So let's substitute this into the formula. Therefore, we are going to have the inverse of A to be equal to 1 all over. Now, what do we have as our determinant is -13. So that is going to affect the whole thing here. It's going to be -1 all over 13 multiplying what is the adjoint of that matrix A. And mind you, we've gotten that adjoint to be -2, 2, and introducing negative signs, we have -3 and -3. So we've gotten all the data we needed to obtain this inverse of matrix A. So let's quickly go ahead and do that. Observing this, you will notice we have a scalar value here, which is -1 all over 13, multiplying a matrix here, which we have those elements to be -2, -3, -3, and +2. And based on the principles guiding scalar multiplication, you will use this scalar value to multiply each element in this matrix, and that is what we are going to do now. Using that scalar value to multiply each element, we are going to have the matrix to be, now the scalar value -1 all over 13 multiplying the first element in the first row, first column, which is -2. We can take it to be -2 all over 1, such that we are going to have, now this negative sign multiplying negative sign is going to be positive, right? So since it's positive, we don't have to write it. 1 multiplying 2 is going to be 2 all over 13 multiplying 1 is going to be 13. So that is to say the elements in the first row, first column for this matrix is going to be 2 all over 13. Now the next one is we use this scalar value to multiply the second element in the matrix. So it's going to be negative 1 all over 13 multiplying negative 3, let's say all over 1, such that it's going to be negative 1 multiplying negative 3 is going to be positive 3. So we don't have to write a positive sign. 13 multiplied by 1 is going to be 13. So that's to say the element in the first row, second column, is going to be 3 all over 13. Now the element in the second row, first column, we are going to multiply negative 13 by negative 1 all over 13 by negative 3, such that it's going to be negative 1 all over 13 multiplying negative 3. Negative times negative, we are going to have positive number. 1 times 3 is going to be 3 all over 13 multiplied by 1 is going to be 13. So we are going to have the elements to be 3 all over 13. And for the last one, this multiplying 2, we are going to have negative 1 all over 13 multiplying 2, such that is going to be, now this is negative sign multiplying a positive sign here, which is invisible, is going to be negative 2 all over 13 multiplied by 1, we are going to have 13. So it's going to be negative 2 all over 13. Now this is the inverse of the matrix A. So the next thing we are going to do is to substitute the matrix A and the inverse of matrix A, which we just obtained, into this formula so that we can obtain the matrix X. So let's go ahead and multiply matrix A and the inverse of A. Matrix B, we have it to be 13 and 1, while we have the inverse of matrix A to be 2 all over 13, 3 all over 13, 3 all over 13, and negative 2 all over 13. So multiplying these two metrics, we are going to have, so to obtain the elements in the first row, first column, we multiply this column matrix by the first row, such that we are going to have, let's write it down, first row, first column is going to be 13 multiplied by 2 all over 13, right, plus 1 multiplied by 3 all over 13. 13 multiplied by 2, we are going to have 26 all over 1 multiplied by 13, we are going to have 13, plus, take this to fraction as well, 1 times 3 is going to be 3 all over 1 times 13 is going to give us 13 as well. So since we have the denominators to be 13 and 13, we put down our 13 as the LCM, then we add up 26 and 3, which we are going to have 29 all over 13. The first element becomes 29 all over 13. Now let's go ahead and look for the second element here, which we are going to multiply the column matrix by the second row, which is this. So let's go ahead and do that. It's going to be row 2, column 2, which we are going to have 13 multiplying 3 all over 13 plus 1 multiplying negative 2 all over 13. Now take this to fraction, which we have 1. 13 multiplied by 3 is going to give us 39 all over 1 multiplied by 13 is going to give us 13. plus take this to fraction as well. 1 multiplied by, now this is negative 2. So 1 multiplying negative 2 is going to give us negative 2. Let's put it in bracket. Negative 2 all over 1 multiplied by 13 is going to give us 13. So let's express this further such that we are going to have 39 all over 13. Now this is positive sign and this is negative, which will give us negative sign 2 all over 13. Now to further simplify this fraction, we have 39 all over 13 minus 2 all over 13. We are going to have it to be, since the denominators are the same, that is to say the LCM is going to be 13 as well, where we go ahead and solve for the numerator, which is 39 minus 2. And finally, we will have it as 37 all over 13 to be the final result for the elements in the second row, second column. 37 all over 13. So this implies that matrix X, which we initially have it to be the variable X and Y, is now equal to 29 all over 13 and 37 all over 13. So that is to say, in a nutshell, this implies that X is equal to 29 all over 13 and the value of Y is equal to 37 all over 13. So that is the value for X and Y which we are looking for. So to further go ahead and check if our answer is correct, all we are going to do is to substitute this value of X and Y into any of the initial equation which we have, either equation 1 or 2, and the left hand side must be equal to the right hand side. So let's go ahead and do that. Let's go ahead and check. So what is the initial equation we have? We have 2x plus 3y equal to 13, or 3x minus 2y equal to 1, whichever one we use. We are supposed to have the left hand side equal to the right hand side. So let's go ahead and pick the first one and use. So we are using 2x plus 3y equal to 13, right? Where we have the value of x to be equal to 29 all over 13 and the value of y to be equal to 37 all over 13. So substituting these values into this equation, we are going to have 2 into the bracket of 29 all over 13 plus 3 into the bracket of 37 all over 13 to be equal to 13. So opening the brackets, we are going to have 2 multiplied by 29 is going to give us 58 all over 13 plus 3 multiplying 37 is 111 all over 13, which is equal to 13. So solving the left hand side, which we have it to be a fraction, adding up to each other. So we are going to have, since the denominators are the same, we have the LCM to be 13 while we add the numerator 58 and 111, which is going to give us 169 to be equal to 13, right? So we can take this to be a fraction as well. Since we have equal sign in between these two fractions, what we are going to do is to simply cross multiply, where this numerator multiply the denominator 1 and this other numerator multiply the denominator 13. So let's go ahead and do that. 1 multiplied by 169, we are going to have 169 to be equal to 13 multiplied by 13 is going to give us 169 as well. So the left hand side is equal to the right hand side. That simply means that our value for x and y is correct. But in a case where you have different value at the left hand side, which is from the right hand side, that's to say your values for x or y is not correct. So you can go ahead and substitute these values for x and y into the second equation, which we have to be 3x minus 2y equal to 1. And we are supposed to obtain your values at the left hand side to be the same thing as that in the right hand side. So that will be all for this video. Stay tuned and engage for the next one. Also remember that goal of this platform is to solve as many past questions as possible just to help you overcome what I called a math exam tension. So if you have any challenging question from this topic which you would like me to help you solve, kindly drop them at the comment section or reach out to me via email or DM and I'll be glad to assist. Thanks for watching and have a great day.